Hello student, welcome in ROSE project in 12th standard which is conducted by Rai Shikshan Sanस्थas. Myself Pawar MH from Sadguru Phadke Maharaj College Karad. Today we are going to take topic number 10, magnetic effect of electric current. My subject is physics. Now let we will see topic number 10, magnetic effect of electric current. Let we will see the topic number 10, magnetic effect of electric current. Let we will see all the contents of the topic. First of all, we will see introduction, magnetic force, cyclotron motion, cyclotron accelerator, helical motion, magnetic force on wire carrying current, arbitrary shaped wire, torque on current loop. Then after we will see moving coil galvanometer, magnetic dipole moment, magnetic potential energy of dipole, Bieseward's law, current in long straight wire, force of attraction between two long parallel wire, magnetic field produced by current in circular arc of the wire. Then after we will see axial magnetic field produced by current in a circular loop, magnetic lines for current loop, Ampere's law, magnetic fields of solenoid and toroid, numerical. Next, today's we will take lecture number first of magnetic effect of electric current. In this lecture, we will see introduction, magnetic and Lorentz force and cyclotron accelerator. Let first of all we will see the introduction of magnetic effect of electric current. Later was see first of all we will see how the magnetic field is produced when the electric field flowing through the or electric current flowing through the any conductor. So any conductor there is magnetic field will be produced. That was first discovered the scientist Hans Christian Ørsted in 1820. That was discovered when the electric current placed near the compass causes the compass needle to be deflected. Why this compass needle to be deflected? Because of electric current there is magnetic needle, there is magnetic field will be produced. That Ørsted experiment shows that every electric current carrying conductor has the magnetic field surrounding it. The magnetic field created by the electric current flowing through the straight conductor act along the concentric circles around it. Now here concentrating circle will be produced in the magnetic field areas. There is the example of the right hand thumb rule here. The direction of magnetic field in the straight conductor is given by right hand thumb rules. Here according to the right hand rule, if you hold the current carrying wire in your right hand, the outstretched thumb pointing along the direction of the current and these stretched thumbs indicates here. See here, outstretched thumbs indicate the direction of the current and this curled finger indicate the direction of magnetic lines. That is the right hand rules. The right hand rules we apply here by using here see the right hand rules. Once again see, when this current carrying conductor held you in your right hand, these stretched thumbs indicate the direction of the currents and the curled finger indicate the direction of magnetic lines here. Now see, we will see the Lorentz or magnetic field. In this Lorentz or magnetic field, we have to take the charge, velocity and magnetic field. According to their C, when the current carrying conductor placed in magnetic field, there is produced the experienced force. That experienced force is known as magnetic force here. That magnetic force will be right. Fm is equal to Q vector V cross vector B. Q means charge, V means velocity, B means magnetic field. Now Lorentz force is the sum of the magnetic force due to the electric field plus the magnetic force due to the magnetic field. The both of the summation we will take for the Lorentz magnetic force. Now finally we can write Lorentz magnetic force Fm is equal to QV cross B. The magnetic force or magnetic field due to the Lorentz force is equal to Fe plus Fb also. Now here is the cross product of the two vectors, so we can write QVB sin theta n, where theta is the angle between V and B. V and B means, V means the, here is The V means there is velocity of particle and B means magnetic field is there. There are three special cases is there. If the charge is the rest position, that is rest position means velocity is 0, then magnetic force is also 0. So sin 0 is 0. So the stationary charge magnetic field does not experience any force. If the charge will be stationary, the magnetic force does not experience any force. If the theta is equal to 0 degree or 180 degree, the charge moves parallel or anti-parallel to the direction of magnetic field. Then sin 0 also 0, 180 also 0. So the magnetic field is 0, magnetic force also 0. If theta is equal to 90 degree, charger moves perpendicular to the magnetic field. The force is maximum here. Here plus q charge direction is upward, minus q charge direction is downward. This is the Lorentz force. Now see, we will see what is meant by magnetic field. If the force is 1 Newton acting on the charge of 1 Coulomb moving with the speed of 1 meter per second perpendicular to B, then we can define the unit of B. Therefore, BV is equal to F is equal to QV sin theta. If sin theta is equal to 90 degrees, so B is equal to F upon QV. Therefore, by unit of B is, unit of force is Newton and unit of charge is Coulomb. Velocity is unit meter per second. So, unit of B we can write Newton second per Coulomb meter. Dimensionally, dimension of the magnetic field is equal to shear. The dimension of B will be F upon QV. The dimension of force is M1 L1 T raised to minus 2 upon dimension of the charge A1 T1 L1 T raised to minus 1. That finally solving this equation we can write M1 L0 T raised to minus 2 A raised to minus 1. That is the dimension of magnetic field. SI unit is Tesla. Therefore, 1 Tesla is equal to 10 raised to 4 Gauss. Gauss is not SI unit, but it is convenient unit of magnetic field. Now, we will see the cyclotron motion when in a magnetic field. Here is magnetic field. If charged particle perform the circular motion, if the charged particle performs circular motion in figure show, the uniform magnetic field directed perpendicular to the plane of the paper and parallel to the negative x-axis. Here is, in magnetic field, the charged particle undergo the circular motion. We show the uniform magnetic field directed perpendicular into the plane of the paper parallel to the negative z-axis. Then we can say this figure shows particle with the charge Q moving with the speed V and uniform magnetic field is directed into the plane of the paper. According to the Lorentz force, the magnetic force on the particle acts toward the center of the circle R, and this force provides the centripetal force. That centripetal force means mv square upon R, and here is magnetic force is there. QVB is equal to mv square R. VV cancel, that mv is equal to P is equal to QBR. It is the cyclotron formula. This is the cyclotron formula. This equation shows the cyclotron formula. Now we will see cyclotron accelerator. First of all, we see the principle of cyclotron accelerator. This is the diagram of cyclotron accelerator. The particle accelerator play important role providing high energy. The cyclotron accelerator used to provide the high energy particle. This energy mega electron holes or giga electron holes. These high energy particle using studying particle interaction useful in the medical treatment of certain tumors or diseases. The cyclotron is charged particle accelerator. Cyclotron is the charged particle accelerator accelerating charged particle with the high energy. It was first invented Lorentz and Lewinson in 1934 for the purpose of studying nuclear structure. So this is the principle of cyclotron accelerator. Both the electric and magnetic field are used in cyclotron accelerator. In this cyclotron, in between the two Ds, here is electric and magnetic field is present. Inside the Ds only there is magnetic field is present. Keep in mind, keep and remember this thing, that sentence. Both the electric as well as magnetic field used in cyclotron in combination. Now see, these are applied in direction perpendicular to each other. Hence, these are called crossed field. The magnetic will put the particle into circular path and high energy electric field accelerate, and the frequency of revolution of charged particle is independent of energy in magnetic field. Here, see here once again, here is 2Ds is there, here 2Ds, and here is charged particle is placed between there. This electric and magnetic field both are perpendicular to each other, and this electric field accelerating the particles here, and here magnetic field is there, put the particle in circular path. The frequency of revolution is particle independent of energy. This fact used in this machine. The cyclotron consists of two semicircular disc-like metal chambers, D1 and D2, called Ds. That's shown in diagram here. The uniform magnetic field here. See here is the cyclotron consists of the two semicircular disc shaped there. So it is called the two Ds, D1 and D2s. That two Ds are there. Here uniform magnetic field is applied perpendicular to the plane of the disc. The magnetic field is perpendicular to the plane of the disc. This magnetic field produced using electromagnet, by using the electromagnet, producing the field up to 1.5 Tesla. How much magnetic field produced by using the electromagnet here? 1.5 Tesla. And alternating voltage up to 10,000 volt at high frequency. And 10 megahertz is applied between two Ds. Positive ions produced by gas ionizing source kept at the point O in between the two Ds. The electric field provides acceleration to the charged particle. The positive ion is placed here in between the two Ds here. Here in between the two Ds positive ion is present. The positive ions are produced gas ionizing source kept at a point O between the two Ds. Once again ions is emitted. It accelerates due to the negative voltage of D and performs semicircular motion within the D, where ion moves from one disc to the another disc. That's here ions move from one D to the another disc here. See here, because of this ion moving from one disc to the another disc, because of the polarities of one disc, negative polarities of there, ion moves. It has a negative voltage of disc, perform the semicircular within the disc. Now see here, next here, that working the accelerate due to the potential difference between the two discs, and again the perform the semicircular motion. Acceleration, the potential difference the two discs, the polarity will be changed there. Positive become negative, negative become positive, and again this the positive ion perform the semicircular motion. Thus ion is acted upon electric field. Everywhere it moves from one D to the another D. The electric field alternating its signs is changed. The circular motion of the ion always is accelerated. Because of electric field there is accelerated. That energy increases. Radius of circular path also increases, making the entire path spiral. Consider an ion source placed at a point P, and ions move in semicircular path. In one of the discs reaches the gap between the two discs. See once again diagram here. In this diagram, Then after changing this polarity of sign, these ions here, the energy of goes on increasing, the radius of the path also goes on increasing. The radius of path became the spiral. Spiral means circular path will be become. So because of here, the circular path will be become, that is the working here. So ds reaches the gap between the two Ds. In time interval, that how much time interval is necessary for to complete the semicircular path, that is t by 2, and to complete the circular full revolution there is time needed t. Using the cyclotron formula we can write mv is equal to qbr, where q is the charge on the ion, t is equal to the time period for complete revolution 2 pi r upon v. After substituting the values of v, that we get m q 2 pi r upon qbr. Then we get t is equal to 2 pi m upon qb, the time period of complete revolution. Now the frequency of revolution is the reciprocal of time period. Therefore fc is equal to 1 upon t. Then we can write qb upon 2 pi m. This equation we get. This is the frequency of revolution. That now see, let we will see here. Then see the frequency of applied voltage 2Ds is adjusted. That polarity will be reversed. Positive become negative, negative become positive. Then the ions in between the 2Ds, त्या दोन्हीच्या मध्ये एक आयन प्लेस केलाय. तो आयन काय होणार, when the polarity reverse केल्यानंतर the ions arrives. The ion कुठे येणार, पूर्ण गॅप कंप्लीट करून वन सेमीसर्कल कंप्लीट करणार. That completing one semicircle, that condition is Fa is equal to Fc, is the resonance condition. That condition is known as resonance condition. The frequency of applied voltage and the frequency of cyclotron motion here. This condition is known as resonance condition. Now see, last upon, the ions do not experience any electric field. In between both electric and magnetic field is present, but inside the disk there is only magnetic field is there. The ion do not experience any electric field. While travel within the disk, their kinetic energy increases. Every time these ions cross one disk to another disk, their voltage difference across the disk, the ions move in circular path, successively larger and larger radius to maximum radius at which they are deflected by magnetic field. The maximum radius, this path will be become maximum radius. So they can extract it through an exit slits. That extracted through that exit slits here in this diagram. See once again diagram. Here excited to the exit slits here, which this energy became in larger and larger. This excited to the exit slits. Last upon, that is the radius of exit slits. This is known as radius of exit slits here. This is the radius of exit. That V is the QBR exist upon M by using cyclotron formula, where R exists is the radius of path at the exit. Now see kinetic energy. Here kinetic energy goes on increase. The kinetic energy of V, the ions oblique protons will be 2m. The kinetic 1/2 mv square. Substituting the value of V, we get Q square B square R square exist upon 2m. This is the final equation of kinetic energy of V. The ions will be here. This final energy is proportional to the square of radius of the outermost circular path. R exists here. This is the cyclotron accelerator. Now we will see the, now we have seen or we have learned the cyclotron principle working. Now by using this video we can understand how the cyclotron work out. See here this cyclotron was first discovered Lorentz and Lewiston in 1934, which is used to accelerate the charged particle. This is used for accelerating charged particle. Now see this charged particle, the charge on the performing here, how the cyclotron works. Consider the motion of positively charged particle moving with velocity v here and entering perpendicular to the uniform magnetic field of intensity. The force acting on the charged particle is QV cross B. We can write QVB sin theta. Sin theta is equal to pi by 2 QVB. The force acting on the charged particle is, we get QVB. Now see, under the effect of these four, charged particle perform uniform circular motion perpendicular to the plane formed V and B. Here, under the effect of these four, charged particle perform uniform circular motion perpendicular to plane V and B. This equation became QVB mv square upon R. R is equal to mv upon QB, P upon QB. V is equal to R omega C. Omega C is the angular frequency of cyclotron. R is equal to mr omega C upon QB. R is equal to mr omega upon QB. This is the cyclotron. Then W omega C is equal to QB upon m and Fc is equal to QB upon 2 pi m. That is. Now here the equation shows that frequency does not depend on the momentum. This equation. Hence the increasing momentum, the radius of circular path also goes on increase, but frequency does not. This equation. This fact used in the design of cyclotron. This figure shows side views and the top views of the cyclotron. Now list figure shows side views and top views of cyclotron here. Two D-shaped boxes kept in their diameter facing each other with a small gap between there as shown in figure. Uniform magnetic field developed in the space. Two boxes, strong electromagnet is there. There see the two boxes are called Ds as there are D-shaped. And AC of high frequency is applied between the two Ds. High frequency is applied between the two Ds. This device kept in evacuated chamber to avoid the collision of charged particle with the air molecules. Now see here working of cyclotron. The positively charged particle release the center of P of the gap of the at a time t is equal to 0. It gets attracted toward the D's. It gets attracted toward the D, negative potential at that time, negative and positive. It enters uniform magnetic field between the D's, perpendicular, perform uniform circular motion. There is no electric field inside the D's. It moves circular path of radius depending upon momentums. Come out D's after the half circle. Come out of D's after the half circle. The frequency of AC, Fa is equal to Fc. The diameter opposite D's became negative. Here, with the particle emerged from one D's, attract it with force increases its momentum. Here, the particle enters the other D's with the larger velocity, hence it moves on circular part of larger radius here. See, circular part of lab. The process keep on repeating and the particle gain momentum, hence the radius of circular path goes on increase. The frequency remains same here. The radius goes on increasing but frequency remains same. The charged particle gaining energy became maximum on reaching circumference of the D's. Here see circumference of the, when the particle is at edges and deflected with the another band brought out and allowed to hit on the target, that such accelerated particle used in study of nuclear reaction, preparation of artificial radioactive substance, treatment of tumor, ion implantation in solids. Now here that is the cyclotron accelerating working. Now some limitations are there. According to this theory of relativity, the velocity of particle approach that of light, its mass goes on increase. In this situation, condition of resonance Fa is equal to Fc is not satisfied. Here, now see here, according to this theory of relativity is there. Here is that to accelerate the very high that light particle is there, like electrons, AC of very high frequency order of gigahertz is required here to accelerate very light particle like the electrons of high frequency of the order of giga. Here is U0. Here to accelerate very light particle like the, it is difficult to maintain uniform magnetic field over the large sized disk. Hence the accelerator like the centrons are developed. This is the limitation, all are limitation of this that cyclotron accelerator. Now let me have understand the working principle and the limitation of the cyclotron. Today's lecture we have seen that introduction, magnetic force, Lorentz force, cyclotron motion, cyclotron accelerator, principle working and limitations of cyclotron accelerator. Thank you very much.